Hello everyone, welcome to section 4.7, which deals with graphs of linear inequalities. So what are our goals for this video / this section? To be able to take an inequality that has two variables, to graph it, to understand the relationship between the solutions and its graph, and then to be able to check, okay? So let's get into it. First of all, what's a linear inequality? They're in the form either ax plus by is greater than some constant, or greater than or equal to, less than or equal to, where a and b are not both 0. Okay, so an ordered pair is a solution if the inequality is true when we substitute the values of x and y. So let's go ahead. So we're talking about y greater than x plus 4. Okay, so we're talking about this here. And we want to check if 0, 0 is a solution. All we have to do is plug in. So plug and chug, right? Or check. So 0, x is 0, y is 0. So 0 is 0 greater than 0 plus 4. So is 0 greater than 4? No. So that means that it is not a solution. Okay. So that's that. And then b, we have b, y is equal to x plus 4. So 6 greater than 1 plus 4. So is 6 greater than 5? Yes. So yes, it's a solution. So this is a solution. And then c, you have here c is 6 greater than 2 plus 4. Here it's 6 greater than 6. No, it's equal to 6, not strictly greater. So this is not a solution. Okay, so this is not. And then let's try d and e. D would be negative 15. Is that greater than negative 5 plus 4? So is negative 15 greater than negative 1? No, it is not. Okay, so not a solution. And then finally, E is 12 greater than negative 8 plus 4. So then is 12 greater than negative 4? Yes, it is. So this is a solution. So only those two, B and E. Okay. So first, let's define a boundary line. So the line with this equation, so the line that, like if you took your inequality and instead of the inequality symbol, you put an equation, you put an equal sign and turned it into an equation, that's what's called the boundary line, okay? So we've been studying graphing lines, and this is where it all comes into play here, and it's going to be handy for you to be able to do. So So when you have an inequality in one variable, the endpoint is the boundary, whether either if it's strictly, we do not equal, it's less than a, or here it's equal to, so you can either do a closed circle or bracket, okay? So when you have a line in two variables, if it's greater than or equal, or greater than or less than, right? This one's less than, this one's greater than, you would say that the boundary line is dashed, okay? So that's similar to open circle in one dimension. Here, if it's less than or equal to, notice this line right here, that means that the boundary line will be solid, okay? All right, so let's look at this inequality from earlier. We have y greater than x plus 4. Now this line right here, this is the line y equals x plus 4, but because it's a strict inequality, it has to be dashed, okay? So all the points to the left, or, in some ways you can think of it up, right? Those are all solutions. So any point that I pick in this area is going to be a solution to this inequality, okay? Okay, so let's see here. Here's the boundary line, y equals 2x minus 1. Let's write the inequality. So it's all the values that have to be. So let's see here. Let's plug in 0, 0. So we know that. So 0, what's the relationship between 0, 2 times 0 minus 1? So what is 0 and negative 1? Is 0 greater, less than, right? It's greater than, right? So that takes care of the inequality part. So any point that's on this shaded inside is going to be greater than. So you would write this y greater than or equal to 2x minus 1, okay? So basically, this is what we do. We identify and graph the boundary line, but if it's a strict inequality, it's dashed. If it's has a little line underneath, the boundary line is solid. Then we test a point if it's a solution. If it's not, we do the other side. If it is a solution, we include that side, okay, because we're going to do shading. So let's see here. Let's graph this inequality, 2/3 x minus 5. So m is 2/3. Like if we think of it as y equals 2/3 x minus 5, we have that m is 2/3 and b is negative 5. So what is that? That's a graph here that intercepts at 5, right? Sorry, I'm making way too many of these hash marks. Okay. All right. So starting at negative 5, so 1, 2, 3, 4, 5, right here, negative 5. And then I'm going to do up 2 over 3. So, okay, so up 2 over 1, 2, 3, and that's going to be my next point. Okay, then I'm going to go up 2, 1, 2 over 1, 1, 2, 3, and then that's the next point right there. Okay, then it's going to go up 2 over 3. Yes, so then up 2, 1, 2 over 3, 1, 2, 3. Okay, so this is the line here. But how do we do, is it shaded? I mean, is it dashed or solid? Because there's this little equal sign, this little half of an equal sign, then it's solid. You do a solid line, solid. So we go ahead and we're drawing this line here, okay? Now, how do we know what side to shade? We use a test point. So we either have, so these are the possible sides. We can either do, everything to the left or to the right. So we don't know which side to shade. So let's pick the origin. That's usually the easiest one. So we test point 0, 0, if it's possible. Sometimes it's not possible to do that. So that if this statement is true, I'm plugging in 0, 0. If this statement turns out to be true, I shade that side. If it's not true, I shade the other side. So we have is 0 less than or equal to negative 5? No. Okay. Well, the origin was on the left side of this, so I'm going to shade this side right here. If I was to do hatch marks or whatever, Yeah, so all of this. So that's your solution, okay? It's all of this side here. Okay. Let's do another one. How about y less than or equal to negative 4x? Okay, so for this one, the line would be y equal negative 4x, sorry, plus 0, because there's no, see how there's no constant, so we assume it's 0. What does that tell you? That means that it's a line that crosses at the origin. It intersects the axes, actually both of them, at the origin, 0, 0. And then it goes down 4 over 1, because m is negative 4 over 1, right? So then it would go down 2, 3, 4. Okay, let's see here. So 6, 7, 8. Okay, so you have down 4, 1, 2, 3, 4, then over 1, and that's your point, the next point. Then you're going to go down 4 again, 1, 2, 3, 4, and then over 1, that's your next point. Okay, so now, is it going to be solid or dashed? We look at the inequality to tell us, oh, okay, it's going to be solid because it has this line right here. So I'm going to just connect the dots. Connect the dots. Right, so I've graphed this line. Now it's, what side do I shade? Do I shade to the left or do I shade to the right? So let's pick an easy test point. Pick 1, 1. So test point is 1, 1. I'm going to plug in 1 less than or equal to negative 4 times 1. So is this true or false? Is 1 less than or equal to negative 4? So the answer to that is no. So we're going to shade the other side. So we're going to shade this side right here. Okay. Not too bad, right? Not too bad, you guys. Okay, so let's do another one. Let's do a straight line here. We have graph the linear inequality y greater than 3. Okay, so you have a graph. Remember that this constant, y equals 3 is a constant going through the 3. But because this is a strict inequality, there's no line, right? It's not like this. It doesn't have this. It's gone, right? So this is going to be dashed. Okay, so dashed. So you're going to have here, da, 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 da. This is y equals 3, but dashed. And now you're going to plug in, you can see here, it's all the values of y that are greater than 3. So it's positive, so it's above, right? 4 is greater than 3, 5 is greater than 3, 6, and so on. So it's basically everything above the line. Okay. All right, what if it was less than or equal to? So if you have y less than or equal to -1, basically, so you start out the same way, except that now instead of a dashed line, you're going to do a solid, right? And also it's not 3, it's -1. So through here, we're going to do a solid line, y equaled -1. And then now it wants all the values that are less than, so it's going to be below, right? This whole side right here. So that's y less than or equal to -1. Okay, this is -1 here. Okay, and that's it for 4.7. The exercises are 505 to 549, odd or every other odd. I recommend the odd for more practice. Good luck and happy studying, and I will see you at the next video.